Okay, so now that we talked about the three classical methods of measuring perceptual processes, especially the absolute threshold, now we'll talk about another construct related to threshold, but not absolute threshold, because absolute threshold is the minimum amount of stimulus needed that Fechner had come up with. Around the same time, there was Weber's who was also working on this and had already discovered some interesting results specific to a different kinds of threshold. It's called difference threshold. And the difference between absolute threshold and different threshold is absolute threshold is the minimum amounts you need to start with to detect. The different threshold is the minimum difference into stimuli that you need to detect the change. For instance, imagine you are driving the car and you have friends in your car and one of them says, "Hey, I can't hear anything. Please increase the volume." And you increase the volume. The let's say the volume is already at 20 and you increase the volume. The question is how much at minimum should you increase the volume by for your friend to detect the change? That minimum additional stimulus that you need to add or remove is the difference threshold. Now this idea was um discovered by Weber. And interestingly, these findings were published in Elements of Psychophysics. So Fechner presented the findings of Weber in his own book. Interesting, right? Elements of Psychophysics were published in 1860, talked about thresholds of different kinds. Threshold called absolute threshold, which was based on Fechner's work, and the findings related to difference threshold, which was Weber's work. This difference threshold Weber found is not constant in amount, meaning if the volume you're playing at is at say 10, and if you needed to increase the volume to for your friend to detect the change, it would be different. If it's playing at 20, so the difference threshold for a given medium, this loudness here, would not always be a constant amount, but it would be a constant fraction of the original amount. So it's always depends on how much volume there already was. If it was 10, you only need to increase by so much for the other person to detect it. If it's already at 20, you need to increase little, you need to increase by more. So it's always a fraction of the original amount of the stimulus. Let's say the fraction is 1/10, and I'm randomly coming up with a number here. So if it is 1/10 of the original one, and the volume at which you're playing music is at 10 decibels, you have to change it by 1/10, meaning 10/10 is 1 decibel. If you're playing at 20 decibels, by how many decimal points do you need to increase it by? Not one, right? 1/10 of the original is 20, so 1/10 of original would be 2 decimal units. So that's what Weber found. We call that Weber's constant, which is constant for a given stimulus, which is always a fraction of the original amount. The beautiful thing is they not only measured thresholds of absolute or difference kind, which gives us a way to quantify the relationship between the stimulus and our experience. But this doesn't directly give us the mechanism behind like the right? Interestingly, you'll see later when we talk about receptor processes, the same idea of threshold, absolute threshold, would be used to explain why and how we experience such phenomenon as dark adaptation. When you enter a dark room, right, what do you see? You don't see anything to start with, right? And the more time you spend, 5, 10 minutes, take like this place here, it's pretty dark, but if you spend a little more time there, then things start to appear, right? Now the question is why? How can you explain this? Well, you learn later that it is because the absolute threshold of our photoreceptors that are sensitive to light changes. When you enter a dark room, the absolute threshold was much higher, meaning that they require more light for you to detect the object. But once you enter the dark room, because the absolute threshold is more and there is no enough light, you won't see anything to start with. But when you spend some time, 5, 10 minutes, then the absolute threshold of the photoreceptors, it goes down as it go, and you measure it. There is a dark adaptation curve, which we'll talk about in the next chapter, where the absolute threshold of the photoreceptors reduces and they start capturing information even when the intensity of the information is pretty low. That is, even in the dark, you start to see things. Now you understand how dark adaptation works. Dark adaptation, it works because of the change in sensitivity of your photoreceptors. And the way we are measuring sensitivity is absolute threshold, which is a way of quantifying the amount of stimulus. So you can see how the work of quantifying the relationship between stimulus and our conscious experience done in the 1860s is used now to explain mechanisms underlying our perceptual phenomenon like dark adaptation. So that's about threshold measures, which includes absolute threshold and difference threshold. Next, we'll talk about above threshold methods.